Hello and welcome to this video. In this video we're going to be looking at how to solve simultaneous equations. We're first going to look at how to do them algebraically, looking at linear simultaneous equations. We're then going to look at how would we solve them graphically, and then we're going to look at some quadratic simultaneous equations and see how we would approach those. So simultaneous equations means that we have two equations that involve two variables that are unknown. So we could take an example. Let's say we have one equation that is 4x plus 5y is equal to 17, and a second equation where 3x plus 2y is equal to 4. So these are our examples of simultaneous equations. They're simultaneous because the same value of x and the same value of y solves both of these equations at the same time. Now there's a general rule. If you want to solve for two unknown variables, you need two equations. If you want to solve for 3, you need 3 equations. If you want to solve for 4, you need 4 equations, and so on. Now the reason for this is because we need to use these equations to try and narrow it down to just solve one variable at a time. So the first thing we need to do is we need to make the coefficients, so make the coefficients, the coefficient just meaning the number in front of this variable, the coefficient of one of the variables the same. Okay, it doesn't really matter which variable you choose. You could make both y's the same, you could make both x's the same. It's really up to you. Both answers will get you to the right thing. So for example, I'm going to make the y's the same in this case. In order to do that, I need to make both of these numbers essentially their lowest common multiple. Now the lowest common multiple between 5 and 2 is quite easy to spot. We're trying to get them both to be 10. If I wanted to get 2 to be 10, I'd have to multiply by 5. But if I multiply just this by 5, I'm changing this whole equation. So I have to multiply everything in this equation by 5, and then I have to do the same up here but multiply everything by 2 instead. And now these equations become, the top equation, if I multiply it by 2, becomes 8x plus 10y is equal to 34. And this bottom equation, when I multiply it by 5, becomes 15x plus 10y is equal to 20. So now I can get rid of these things. So now my second step is to eliminate that variable. And how I'm going to do that is I'm going to either add or subtract. So by adding / subtracting these two equations from each other. So adding or subtracting the equations is going to allow me to eliminate one of these variables. So I've already made y is the same. To get rid of these, I'm going to have to minus them from each other, and so I have to minus everything. So 8x minus 15x is going to give me a minus 7x. 34 minus 20 is going to give me 14. Okay, because the 10y minus the 10y gives me nothing, and so I get a new equation here where minus 7x is equal to 14. Now I can solve this because I only have one variable. So my third step is to solve for variable that we have. In this case it's x because we got rid of the y's, and this variable is going to solve to be minus 2 because we're going to move the minus 7 over to this side by rearranging. And if it's multiplied by minus 7 on this side, it's divided by minus 7 on this side, and 14 divided by minus 7 is going to give you minus 2. And then our final step, so we've solved for one of these variables. Remember, these are simultaneous, so we have two variables we need to know. We need to now take this variable that we know the answer to, put it back into any of these four equations. I would generally recommend going for the one with the smallest numbers because it makes it easier to solve, and then solve for your next variable. So substitute the value back into equation and solve. Okay, so if you're ever in a situation where you need to solve a simultaneous equations, these are the four steps you want to go by, as long as they're linear. Okay, so now to solve for y, this is probably going to be the easiest equation to use because they're the smallest numbers. So I'm going to say 3 times minus 2, since the x is now minus 2, plus 2 times y is equal to 4. And now 3 times minus 2 gives me minus 6. So minus 6 plus 2y is equal to 4. I'm going to move this minus 6 onto this side, and that's going to be plus 6 then, so it's going to give me 2y is equal to 10, and therefore y is going to be equal to 5. And now we know our solutions to this simultaneous equation, or these simultaneous equations. And you can always do a check. You can always substitute back in your value for y or your value for x into one of these and make sure you're getting to the right answer for these. Now this is how we want to do it algebraically. If we wanted to solve these things graphically, so solving them graphically means we're going to have to rearrange them slightly. So let's have a go at that. So let's say if we wanted to take the 4x plus 5y equals 17 and plot that out as a y equals mx plus c graph, we're going to have to rearrange this first to figure out what y equals mx plus c form of this expression is. So I'm going to have to move the x onto this side. So 5y is going to give me 17 minus 4x. And then I need to divide by y to make sure I'm getting a y equals, not a 5y equals. So if I divide by 5, I get 17 over 5, which I'm going to leave as a fraction, minus 4 over 5x, which I'm also going to leave as a fraction. So this is my first equation. And then my second equation is going to be 3x plus 2y equals 4. I'm going to do the same thing, minus the 3x across. So 2y is equal to 4 minus 3x. And then divide everything by 2. Y is equal to 2 minus 1.5x. So this is my second equation. Now I can plot these on a graph. And when I plot them, I'm going to find, so if I move this up to here, just looking at these, if I get a rough sketch of what these axes are going to look like, where this is my y-axis, this is my x-axis. If this is traveling through 17 over 5, 17 over 5 is roughly about 3.4. Okay, so let's find where 3.4 is, and let's put it here. Okay, so we know it has to pass through this point here, and it has a gradient of negative 0.8. So 4 over 5 is going to give you negative 0.8 gradient, which means it's probably going to go something like this, okay, roughly. Now this one is going to have a y-intercept of plus 2, so it's going to go through something about there at plus 2. Obviously this isn't to scale, but its gradient is going to be minus 1.5, which means it's going to have a much steeper gradient, and so it's going to go through here. So what you're going to find is that these lines are going to intersect about here. And if you were to plot these lines properly on a graph, obviously this is just a rough sketch, but you would actually find that this will have a y value of 5 and an x value of minus 2. And so solving them graphically, we're basically just going to plot our two lines and look where they intersect, and that's going to tell us the coordinates of y equals 5 and x is equal to minus 2, just as we expected. So this is how we're going to solve linear simultaneous equations. Now let's have a look at how we're going to solve quadratic simultaneous equations. So quadratic equations, or simultaneous, quadratic simultaneous equations. The idea with quadratic simultaneous equations is we're going to have some x squared, or maybe even a y squared sometimes, because these things are quadratic. So for example, a example of a quadratic simultaneous equation might be that, for example, x squared plus y squared is equal to 36, while x is equal to 2y plus 6. So this is our example of a quadratic simultaneous equation. We know it's quadratic because we have these x squareds. Just as a side note, this first thing here is actually the equation of a circle. Okay, if you're not familiar with what the equation of a circle is, it usually has both an x squared and a y squared, and this is just going to be the radius of the circle squared, which we're going to see when we're going to have a go at seeing how we'd solve this one graphically as well. But what we're going to do is we're going to say that since we know x is 2y plus 6, our first thing we wanted to do before was to somehow get rid of one of these variables. And if I substitute in x equals 2y plus 6 into this x squared up here, then I get rid of all x's in this expression. And so that's what I'm going to do. I'm going to substitute, so I'm going to say 2y plus 6 squared plus y squared is equal to 36. Now I'm going to expand these, so when I'm expanding brackets, I have 2y plus 6 times 2y plus 6 plus y squared is equal to 36. I employ FOIL. If you remember, it's first, outer, inner, and then last. So I multiply the first two, which is going to give me 4y squared, the outer two, which gives me 12y, the inner two, which gives me another 12y, and then the last two, which gives me 36, and then plus the y squared is equal to 36. Now I can move this 36 to this side and also collect some like terms. So I can say that when I simplify, my 4y squared plus the y squared becomes 5y squared. 12y plus 12y becomes 24y, but then 36 minus the 36 becomes equal to 0. So I don't actually have to solve a quadratic equation here because I can just factorize out a y. And I could say that let's take a y out, and that's going to be 5y plus 24. And that means that's equal to 0. So either, because this is quadratic, we're going to get more than two solutions. So we'll write our solutions over here in the corner. So either y is equal to 0, since when we're solving equations like this, one of these things has to be equal to 0. And so either y is 0 or 5y plus 24 is 0, in which case y should be equal to minus 24 over 5 from rearranging this. So I'll do this explicitly up here. So 5y plus 24 is equal to 0. So minus the 24, 5y is equal to minus 24, and y is equal to minus 24 over 5. Okay. Now we need to work out not only what the y values are, but also what are the x values. So we want to take these values and substitute them back into these expressions. Again, doesn't matter which one you choose. I would obviously recommend doing this one because it's much easier. But each y value is going to correspond to its own x value, and hence they're going to be the coordinates that we're going to see are the intersections in the graph that we plot in a second. So let's put in y equals 0 because that's going to be easiest. So when y equals 0, x is equal to 2 times 0 plus 6, which means x is going to be equal to 6 when y is equal to 0. Now if y is equal to minus 24 over 5, then x is going to be equal to 2 times minus 24 over 5 plus 6. And minus 24 times 2 is going to be minus 48. Minus 48 divided by 5 plus 6, so minus 48 over 5 and then plus 6. We could change this 6 into being 30 divided by 5. And so we could write this, I'm just going to write it a bit over here so I leave space for my answer. This plus 6 is going to be 30 over 5 minus 48 over 5, which is going to become just 18 over 5, or minus 18 over 5. So when y is equal to minus 24 over 5, x is equal to minus 18 over 5. And these are our four answers to this simultaneous equation. And then if we wanted to plot these out, we would have to first of all plot out this x squared plus y squared equals 36. So let's just rewrite these down here. So let's say graphically, what we're solving is x squared plus y squared equals 36. And our second one is x equals 2y plus 6. So this x squared plus y squared equals 36 is a circle with a radius of 6. So at 6 at every point, it's centered on the origin, and so it's going to be 6 everywhere, and it's just going to be a circle that passes through all of these points. Obviously it would be a perfect circle if you were to properly plot this. And then from there we'd have to change the form of this equation, so we'd minus the 6 across, so 2y is equal to x minus 6, and then divide by 2, so y is equal to a half x minus 3. So if it's going to pass through minus 3 and it's going to have a gradient of a half, it's going to go through like this roughly, and you'll find that when we look at our solutions that we get, this down here, this coordinate here is going to be minus 18 over 5 minus 24 over 5, and this coordinate up here that we're going to get, this is a terrible sketch of this. This should actually be pass through 0, 6. Again, this is a very rough sketch of what we're doing here. If you were to plot it, well, that's an awful circle as well, but it would pass through minus 3, and it would also pass through 0, 6. So that's where you're going to find your solution, or 6, 0 even. Okay, so the last part got a little bit messy just because I can't really draw graphs, but the principle stands. If you were to be given a graph and asked to solve for where the solutions to your simultaneous equations are, they would just end up at the intersections, and those would be your answers for your x and y values. So we're going to start off with a relatively simple one, and then we're going to slowly get harder. We're going to look at a graphical example, and we're going to look at 2 quadratic examples, where the last one is going to be quite tough. So if you remember, in the revision video we had 4 steps. The first step was to make one of these coefficients the same. I said it's up to you which one you want to do. Both of them are completely fine. In this case, I'm going to choose to make x's the same. Okay, and in order to do that, I have to multiply everything in the top by 4 and everything in the bottom by 3, since the lowest common multiple between this 3 and 4 is going to be 12. And what happens then is these equations become 12x when I do the 4 times the 3x, plus 28y, the 4 times the 7y, plus 26 times 4, which gives you 104. Now the second half, or the second equation, is going to become 12x plus 15y, and then that's equal to 39 with the 3 times the 13. Now that we've got 2 things that are the same, we can minus these 2 equations from each other, and that means that we can eliminate these x's and just solve for these y's. And if we do that, 12x minus 12x gives us nothing. 28y minus 15, well, 28 minus 15 is going to give you 13, so that's going to be 13y, and then 104 minus 39 is going to give you 65. And so then if we want to solve for y is going to be 65 divided by 13, and 65 divided by 13 is just 5. Okay, so now we have y, and then we said as soon as we have the value for 1, we want to take that value and plug it into one of the original equations in order to work out x. I'm going to plug it into this bottom one purely because it just has slightly simpler numbers. So 4x plus 5 times y, but y is 5, so 5 times 5 is equal to 13. When I expand that, 4x plus 25 is equal to 13. Then I can solve this for x now, so that I have no other variables, I just have x. So I can say 4x is going to be 13 minus 25, and 13 minus 25 is going to give me minus 12. Then x is going to be minus 12 divided by 4, which is going to give me minus 3. So my answer that I would write down here is that x is minus 3 and y is equal to 5. So let's now have a look at how we would solve something in a more graphical sense. So they've already plotted out for you the line of y plus 2x equals 5. And they want you to complete this table because they have a second equation here that they want you to be able to solve. So completing the table, all we're going to do is take the values of x and substitute them in. So y must be equal to 2 times minus 1 minus 1. 2 times minus 1 gives you minus 2, minus the extra 1 gives you minus 3. Y equals 2 times 1 minus 1. That's going to be equal to 1. And you can notice now each time I'm just adding what the gradient is. And the gradient in this case is 2, so up here 5 plus the 2 is going to give me a 7. So I've completed that table then. And then what they ask is, on the grid, draw the graph of y equals 2x minus 1. So I need to plot out all of these points. So I go x is minus 1 and minus 3, which is here. Then I say x is 0, that's going to be minus 1, which is there. Then when x is 1, y is 1, which is there. When x is 2, y is 3, which is up here. And when x is 3, y is 5. And then finally, when x is 4, y is 7. Now I have to draw a straight line through these, so you'd get your ruler, and then you would do a line of best fit. This line is a little bit skewed. But you get the idea. You'd want to be more accurate. And so the idea of this then is they ask you to use your diagram to solve the simultaneous equation. So the first equation is what they've given you in the question. The second equation is what we've plotted. And so we said before, the solution to this equation is just going to be the point where they intersect, which is this point here, which we can read off is going to be x is 1.5 and y is 2. And so those are the solutions to this simultaneous equation. Now let's go a little bit further and have a look at a quadratic equation. So this quadratic equation says that we have this equation of a circle again, x squared plus y squared is equal to 9, and x plus y is equal to 2. So what we did before is we rearranged this and we said that x is equal to something and then substituted x in. We're going to do that again. We could easily also rearrange for y and substitute y in if you so wish. It's really up to you which way around you want to do it. But let's say if x plus y is equal to 2, that means that x is going to be equal to 2 minus y. Okay, so just rearranging this to minus the y across to here. And this is the equation that I'm going to substitute into x squared plus y squared is equal to 9. So x is 2 minus y. So I have 2 minus y squared plus y squared is equal to 9. I can expand these brackets. So 2 minus y times 2 minus y plus y squared is equal to 9. This is going to become, when I multiply the first two, I get 4 minus 2y minus another 2y and then plus y squared from the minus y times minus y plus another y squared from what's given in the equation is equal to 9. So I can simplify this and it's going to give me 2y squared from the y squared plus the y squared minus 4y from the minus 2y minus 2y, and then it's going to give me minus 5 is equal to 0. So I'm going to minus the 9 across, and 4 minus 9 is going to give me minus 5. Now this is the equation that I have to solve now. And so there are multiple ways you can solve quadratics. We could apply the quadratic formula, but let's first have a go at trying to factorize this. So factorizing 2y squared minus 4y minus 5 equals 0. In order to factorize something where we have a non-zero or a non-unity value for y squared, unity just meaning 1, so because we have 2, we're looking for two numbers that multiply to give 2 times minus 5, so minus 10, but add together to give minus 4. Now I said if this is not immediately obvious, you can always make a list of things that multiply to give you 10, so maybe 10 times 1, maybe 2 times 5, and this would be almost about it. And you can kind of already tell from this, we're not really going to be getting any nice values that are going to be able to solve this. And so what we're going to do is scrap this idea and then just throw it into the quadratic formula. In order to skip this step and notice that they want things in the quadratic formula, this sentence is the hint. Okay, if they want things to a certain amount of decimal places, the quadratic is probably not going to simplify very nicely. So what we're going to say, we're going to get rid of all this, and we have to remember the quadratic formula is that x, or in this case we're going to call it y, is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a, where 2 is a, minus 4 is b, and minus 5 is c. So when we put that into the equation, y is equal, let's separate it first, so we'll say let's take the plus sign. So y is going to be equal to minus 4, which is going to be plus 4, plus the square root of 4 squared, which is 16, minus 4 times 2 times minus 5, all over 2 times a, which is 4. Now we could simplify in here and saying that minus 4 times minus 5 is going to give me minus 20, and then 20 times 2 is going to give me, minus 4 times minus 5 is going to give me positive 20, and positive 20 times by 2 is going to give me positive 40. So in here we're going to say that y is equal to 4 plus root of 56 divided by 4. Now the converse of that is this is going to be 4 minus root 56 over 4. Okay, and so now these are our two solutions, but as they say, they want them to 2 decimal places, so you have to grab your calculator and you type in 4 plus root 56 divided by 4 gives you 2.87 to 2 decimal places. So y is equal to 2.87, and if we make that a negative instead and look at our other option, y is equal to minus 0.87. So these are our two solutions. So I'm going to write them over here just to try and make things a little bit neater. So y is equal to 2.87 and y is equal to minus 0.87. Okay, so now we have our solutions for y. We need to go back and solve for these solutions for x. So we're going to go back to this equation here and just substitute in our different values for y. So if x is equal to 2 minus 2.87, then x is going to be equal to minus 0.87. And if x is equal to 2 minus 0.87, minus always becomes a plus, and that's going to be x is equal to 2.87. So you can see there's kind of a symmetry or an anti-symmetry here. But those are our two solutions. These are our solutions to this quadratic. Let's have a go at one more quadratic that's going to be a little bit more challenging. So we have the same thing. We're going to again rearrange for, let's go for y in this case to try and keep everything positive. And we're going to substitute the y expression into this first equation. So if I want to rearrange this, it gives me y is equal to 3x plus 13. Then if I have x squared plus y squared is equal to 25, this y is equal to 3x plus 13. So this becomes x squared plus 3x plus 13 all squared is equal to 25. Now I can expand this and I get x squared plus an expansion, which is going to be 3x plus 13 times by 3x plus 13 is equal to 25. Now 3x times 3x is going to give me 9x squared. 3x times 13 is going to give me plus 39x. 3x times 13 gives me another plus 39x, and then 13 squared is going to give me 169, and that's equal to 25. So I can pull together some like terms x squared plus 9x squared gives me 10x squared. 39x plus 39x, well 39 times 2 is going to give me 78x. And then lastly I have 169 minus 25. So 169 minus 25 is going to give me 144. So plus 144 is equal to 0. Now, these are quite large numbers. I can simplify this a bit by just dividing everything by 2. Okay, so if I divide everything by 2, I get a 5x squared plus a 39x plus a 72 is equal to 0. Now I can't simplify this any further because nothing is a common multiple of these three. So you could try to find something that's going to factorize to get to this, but you're going to be working with something that's 5 times 72, which is going to be 360, and then looking for something that multiplies to give you 360 and adds to give you 39. And that's probably going to be quite difficult. So I would say, as a simpler escape plan, let's just put it into the quadratic formula. And so we're saying that x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. So our expression is that x is equal to minus 39 plus or minus the square root of 39 squared minus 4 times 5 times 72, all divided by 2 times 5, which is 10. Now we can simplify inside here. So if we put in 39 squared minus 4 times 5 times 72, we get 81. Okay, so this becomes x is minus 39 plus or minus the square root of 81 over 10. Now this square root of 81 is actually a whole number. We could write this as x is equal to minus 39 plus or minus 9 over 10. And so this is going to give us our two solutions. If we take a plus sign in here, it becomes x is equal to minus 30 over 10, which is basically going to be equal to minus 3. So let's write over here, x is equal to minus 3 is one of our solutions. And then our second solution is going to be what happens if we minus this. And if we minus that, we'd get x is equal to minus 48 over 10, which is going to be equal to minus 4.8. Okay, so that's our second solution. So x is either equal to minus 3 or x is equal to minus 4.8. Now to solve that, we're going to substitute these back into this expression at the top here. If y is equal to 3 times x, which is minus 3 plus 13, 3 times minus 3 is going to give me minus 9. Minus 9 plus 13 is the same as 13 minus 9, which is going to give me 4. So y is equal to 4 when x is equal to minus 3. So we can write that here. And on the flip side, y is equal to 3 times minus 4.8 plus 13. Well, 3 times 4.8 is equal to 14.4, but that's going to be negative. And so we're going to have 13 minus 14.4, which is going to give a y value of minus 1.4. And so when x is minus 4.8, y is minus 1.4. And these are our solutions to this algebraic quadratic simultaneous equation. Hopefully this all makes sense, and thank you for watching.